Hey guys, good morning. How are you? Are you feeling like that days are going very fast? Mhm. No? Not? Yes. Should I feel the same? Days are going very fast. So what is the reason why days are going very fast? Huh? Why? We are slow. Days are going very fast because everyday routine work. When you do different work, you feel like the day is very long. When you do the routine work, you feel like the day is very, very like small. So my life is very, very boring life nowadays. Same. You are attending only 1.5 hour class. Chalo, and this is the last algorithm in machine learning and the level 1 algorithms. Okay. So again, I'm repeating the same story. The machine learning. We cover the first algorithm is the regression type. What is the regression meaning? The output label is numerical. Output label is what? Numerical, and the algorithm name is linear regression. Linear regression. And second one is we have done the classification. Classification. What is the meaning of classification? Output label is categorical. Why discrete? Kya? Sorry. And the first algorithm will end logistic regression. And second algorithm is decision tree. And third algorithm is Navi Bayes. And fourth algorithm is KNN. And then we started with cluster. That means output label is not present. So in that, bolo. Voice is not audible. Can you please confirm the chat? Am I audible to you? Clear, Utkarsh? Clear? Very good. We are laughing. Yeah. Output label is not present. And one algorithm is called k-means. Another algorithm is called hierarchical. Now in the linear regression, what is the mathematics? That is main mathematics, nothing but a OLS. It is simply differentiation, right? The differentiation. And the logistic regression, what is the mathematics? Sigmoid function. Sigmoid function is the, and in the decision tree, entropy and Gini. And Navi Bayes is nothing but a probability multiplication theorem. Probability multiplication theorem. And KNN is the distance metric. Euclidean distance. And here K means what happened now? Here also a distance metric. So now you do one thing. For every algorithm, what is the mathematics? Just note down the bullet points in somewhere kind of thing. Take one page. So this algorithm, this is the mathematics, and this is the formula. Like some dot connects. If the interviewer asks what is the logistic regression, so sigmoid function I need to talk. If interviewer asks what is the naive bias, I need to talk about multiplication theorem. I need to talk about assumption. I need to talk about Laplacian theorem. That the main bullet points. For every algorithm, main bullet points you need to write it. So that is important. And the K means is a distance metric. Now here, lasso regression that we need to cover. And ridge regression. Need to cover. And lasso regression, ridge regression basically is a kind of a regularization techniques. It is not the specific algorithms, it is a techniques called regularization techniques. So that's why we'll cover at last after the algorithms are completed, regularization techniques and optimization techniques. So it is kind of a regularization techniques. If somebody said it is algorithms, it's not algorithms. Regularization techniques. What happened, Nakal? One institute has approached to me about data science course. You can't believe by seeing their course curriculum. I'll just share that, okay? Just show you that. See how they are fooling that people. It's very bad in outside. Give me 1 minute. See this. So this is their statistics for data science. Okay. Data understanding, descriptive, summary, tabular, probability, hypothesizing, chi-square, ANOVA, correlation, linear regression, and this is R for analytics and machine learning with R, then done. That's a data science course. And they have students also, and they are charging 65,000. They are charging 65,000 and they are teaching R. No Python, no SQL, nothing, no deep learning, no NLP, no generative AI, nothing. And this is they are approaching that. No, I'm not ready to take this. I told them, where is your deep learning? Where is your NLP? And you are saying data science course. And at last, they are implementing artificial neural networks, ANN. And that also they want to implement using R. That's completely a bluff. AI techniques, they are implementing R. How that possible? That is, so this, like this are there people. And is this in Bangalore? The Bangalore company. Okay, that's why if you are suggesting anyone also, please tell to them, inquire very properly. What is the course curriculum? Go to IITs, NITs, download the brochure, what they are teaching, what other institutes are teaching. Like that, you need to verify that. Not only this, in future, anything also, you need to understand the reference materials. See this people, 65,000 they are charging. 65,000. And that is only 1 or 2 months we can finish, that is. So this regularization techniques, that only if I am the teacher, they will say that don't know extra classes. That only the things if you need to teach means what students will believe. Okay, that is the only syllabus might be. Then after going outside, then you will scold me, pakka. Like that. That is the scenario. So whatever teacher will convey, that is the only syllabus, because some people are not teaching OLS also. And whenever you are discussing with some other people OLS, they will other people are getting shocked. Then why faculty are not covering the OLS? So like that, so it is kind of, things. So next, some algorithms are there, SVM is there, and bagging, boosting algorithms are there. and recommendation engine is there. Engine. वो recommendation आता ना, movie recommendations. These are the algorithms. Polynomial, multinomial is generally they will not cover, or logistic regression only be done, right? That is logistic regression, nothing but only that curve. That is. Then these are the algorithms, and there are some other things are there, many things, especially machine learning concepts. One is you need to pakka learn these kind of things. One is PCA, that is nothing but principal component analysis. Principal component analysis that you need to learn. You already learned bias and variance trade-off. You know that what is overfitting, what is underfitting, what is normal fit, that you already know that is. That means overfit, you know, underfit, normal fit. And then especially you want to learn optimization techniques. Optimization techniques. Optimization techniques, which means how to avoid overfitting. Overfitting. Pakka they will ask you in the interviews. These pakka questions, no doubt in that. These are the pakka interview questions. Okay, what are your, how can you achieve the overfitting? How can you avoid the overfitting? Regularization techniques. Regularization techniques. Then how can you speed up the process? Regularization techniques. Feature selection methods. Feature selection methods. Hyperparameter tuning. This is for every model. The concept is same, whether it is the deep learning, whether it is the NLP, whether it is ML, these concepts are same. The extra. These are the algorithms. These are the algorithms, and this is the extra knowledge to understand the model things. Important topics, you can say that. Principal component analysis, bias and variance trade-off, overfit, underfit, normal fit, optimization techniques, regularization techniques, feature selection methods, hyperparameter tuning that you need to learn. And anyhow, again, our famous metrics will be available with you. Metrics, all the regression metrics, all the regression metrics you need to learn. Regression metrics, classification metrics, classification metrics, and next one is cluster metrics. These are the concepts you need to learn, as well as how to run the Python code also you need to learn. Then your machine learning is completed with this completely. Again, these concepts are is same for deep learning, NLP, and machine learning. Okay, if you complete that above algorithms, if you completed this metrics, then you can ready for apply the jobs. Okay, create a some normal resume with another mobile number, with another email ID, and try to give the interview calls. So definitely they will ask these kind of questions only. See the JD, then apply for machine learning. Then anyhow, we'll start the deep learning. That is in the next week after the completion of ML. And slowly what happen, you can get the exposure of interview exposure. Maybe your luck is good, you can get the job with this only. Machine learning. That is. But that is not possible. As a data scientist tag, you need to learn everything. You need to learn ML, DL, and NLP. Not like this. Okay. Not like this, ma. Who are enrolling for this course? I am shocking that. They are saying that they have students who are enrolling for this. That means that is very bad, that is. Yeah, forecasting model is also there. I am saying that ML thing, okay? I am saying this ML thing as of now. That is, these are left in the ML. The regularization technique we need to shift. Technically, we are now only 4 algorithms are there now. That is, we'll cover this today now, and next 3 are there. And anyhow, we'll cover this. And deep learning first week is very, very important. Ma, if you miss the first week classes, you don't come to the next week. Okay, simple. If you miss the first week classes, don't come to the next week. Deep learning first week is important. And NLP is anyone can do that. NLP, you can do the analysis. That is okay, fine. At any come you can attend. But deep learning, if you miss the first week, don't come to the next week. You will not understand. That's the time waste. Chill karo. Okay, next week. So that is a much important first week. Yeah, let's start now. Hierarchical. So understood that now roadmap, right? This is the roadmap. And that is same thing you can identify in the syllabus copy also. Same thing that is. Chalo. There are 2 types of algorithms are there under this cluster algorithm. One we already seen about that. K means in that K is nothing but a number of groups. Number of groups. It is nothing but a hyperparameter. Hyperparameter. In the KNN, K is nothing but number of neighbors. Number of neighbors. And that is also kind of a hyperparameter. Both are using Euclidean distance metric only. Distance metric only. But the key difference is KNN is nothing but a simple small calculation only. That is calculate the distance. Calculate the distance between observations in that one observation is your test data, test sample, and another observation is generally neighbors. Another observations are neighbors. And finally you will take majority vote. This is generally we will do in the KNN. You will pass the test data and test sample will calculate the distance between the observation. One observation is what? Test sample. Another observation is what? Neighbors. And finally we'll take what? Majority vote. But here what you are doing? Here we'll calculate distance between observations with group of means. Whichever is the lowest distance, we will push that observation to other group. Whichever is the lowest distance, then that observation will go into that group. When observations are updated in a group, then what happens? The means will change. What will change? Mean will change. So that's why we'll repeat this process. Till the means are fixed. So this is K-means. This is a K-means. Don't confuse, don't explain in interview opposite. KNN, K-means ko, KNN ko, don't explain that in interview. Both are using distance metric, but this we can say that what is happening K-means means explain exactly this. What is happening KNN exactly like this. Write this kind of bullet points for every algorithm by your own self. Write this kind of bullet points. Take a fresh notebook, buy one classmate notebook and take the one algorithm. Every algorithm is one bullet points. I noted like that only. When I am in my college days, no, I have taken one book and I have taken every algorithm one book, one page. Every algorithm one page. For the interview preparation. For the interview preparation, note down like this. Then you can revise that very quickly. Revise it very quickly. No, not this is not shocking. The syllabus copy is shocking. Okay. Syllabus copy is shocking. So next algorithm is called hierarchical clustering. Group में మీన్స్ చేంజ్ అవుతాయి అది మళ్ళీ నువ్వు ఇంకో ఇటరేషన్ చేసినప్పుడు మళ్ళీ ఫిక్స్ అయిపోద్ది కదా ఇప్పుడు సెకండ్ ఇటరేషన్కి ఫస్ట్ ఇటరేషన్ సపోజ్ ఫస్ట్ ఇటరేషన్ mean is suppose 1,5. Okay, and the groups are suppose taking 5 groups, 1, 2, 3 in one group and 4, 5 another group. Second iteration, when you take the second iteration, then suppose mean is nothing but second iteration what happened, groups will change. Now 1, 2 is another group, then 3, 4, 5 is another group, correct? Think like that. Now what happened, definitely what will change? Mean will change. Now mean is equal to suppose 5, 6. Now you've done the third iteration same like this. You are calculating the distances between the means and everything. Means and everything. Even though when you calculated also, your group members are not changing. 1, 2, 3, 4, 5 only happened. 3, 4, 5 only happened. When you conduct the mean, again what happened? 5, 6 only will come. The distance value will change. We are not considering the distance value. We are considering lowest distance or highest distance. This iteration, when you calculated in this iteration, 1, with 5, maybe that lowest distance will come. Another iteration, highest distance will come. We are comparing the lowest and distance values only. That's it. So now, how many iterations you will do, then this value will be what happened? Fixed only. Because the group members are fixed. It will never change. Group members change and would mean at the same the observation same. Then your observation 2. Okay, I understood your question. So you might saying that second observation value and third observation value is might same. That is interrelated, right? Observations are same means that relation is same. That means you are not considering kind of those observation. No, you are not concentrating on that. See, second observation and third observation both are same. Then only you are shifting second to third, third to second. So if observations are same means it will go to which group? It is not that matter, no? It is not that much matter. First if second is going to first observation. Third is going to second observation. Second group. Now these are interrelated. So that is not matter. Because the values are same. Values are same. That is a good question, but that is not that matter. That is. Yeah. Hierarchical means what happened? First, it will consider every observation is one group. Every observation is one group. Aggregate clustering, observe that every observation is one group. That means every family, think like that, every home is one group. In a city, you need to think like this. Take one city. Take one city. Take some Hyderabad only. In that Hyderabad only, suppose especially Amirpet you take. This is entire Hyderabad. In that some area, every household is one group. Every household is one group. This is one group. This is one group. This is one group. This is one group. And this is one group. This is one group. Now we'll calculate the distance between which each and every one. That means there are 5 houses are there. 1, 2, 3, 4, 5 is there. Now how many distance metrics will happen? How many distance metrics will happen? 1 to 2, 1 to 3, 1 to 4, 1 to 5, 2 to 3, 2 to 4, 2 to 5, like that. Now whichever is the lowest distance, and they will combine together. They will combine together, and slowly everyone will start with 1 and 2, 3, 4, 5. Maybe first these guys will approach, then these guys will combine. Okay, that means this observation is one group, and this observation and this observation another group at some point of distance. If you increase the distances, again these guys and these guys, so this entire line, horizontal line you are seeing, right? These 3, these 2 also can combine together at some point of distance. As distance is increases, you can combine all at one place. Suppose Amirpet is one area, Madhuranagar is another area, Kukatpalli is another area. Kukatpalli is one cluster, Amirpet is one cluster, Madhuranagar is one cluster. At some point of distance, everything you can see as a Hyderabad. At some point of distance, everything you can see as a Telangana. At some point of distance, all states are combined together as India. At some point of time, all are Asia. At some point of all are complete world. That means all observations start as the individual clusters, and finally at some point of distance, everything will be what happen? One cluster. In that, how many clusters you want to choose? That is your wish. That is your wish. That means it will come like this. So it will come like this. So this is one line, and this is the another line. Now this is one observation, first observation. First observation, second observation, third observation, fourth or fifth, suppose. At some point of distance, out of these 5, 1 and 2 are making a cluster, and 3 and 4 and 5 making a cluster. But means these are very, very close each other. These are very, very close each other. At some point of distance, again these 2 guys are very, very close each other. That means these all are formed with what? Together what? One cluster or not? At highest you will see one cluster, at lowest you will see many clusters. And that is the idea about hierarchy. Hierarchy means what? The step by step. Hierarchy. Oh, this is called generally, you'll see here. This is called dendrogram. What the name is called? Like this. Dendrogram. Every observation, there are so many observations are there. Every observation is one cluster. Like imagine like this, 5 observations. Everyone is what happened? One cluster. Now at this distance, this is. Now suppose there are 7th observation, 6th observation is there. seventh observation is there, and the eighth observation is there. In some point of distance, 6, 8 is from one cluster. 6, 8 is from one cluster. At some point of distance, maybe 7 with this guy will form one cluster. And slowly what happen? At last point, everyone become one cluster. See, at 14th line, everyone become what happened? Before 14th, how many clusters are there? 1, 2. You are cutting a line. How many clusters will form? See, when you cut the line, this is 1, 2, 3, 4, 5, 6 clusters. How many clusters you want to choose? You can cut the line. At this distance, everyone is a cluster. Think like that a family relation. Our father, mother, and brothers and sisters are very, very tight together. That's a very, very distance is very, very less. Relation is very high. And slowly you increase your relatives. Okay. Delhi में मेरा पापा मेरा चिचा है, and Hyderabad में मेरा auntie है. And slowly what happens? The distance will increase. Then all together what happens? One family. That is the idea. Suppose you are getting married, then whom you want to invite? Then cut the relatives. How many relatives you want to do? Okay, like that. Only one. Only you and your wife. That's all. Love marriage or what? Understood now this concept? And this is nothing but how can we achieve this? That is the question. How can we achieve that is a question. And for that, if you do the sample program only, then only you'll understand. Okay. This is actually my professor PPT. I copied from there. That's why you'll see R code is there. Still, I'm not editing this. R code is there. Okay, chalo, we'll do the problem, then you'll understand. Note on the problem. This is the problem. Note on the problem. Now there are 5 observations are there, A, B, C, D and A, B, C, D. Note on the 5 observations. Whenever you read theory, you will not understand. You do the problem only, then only you will understand. Okay. A here, B, C, D and E. Then A, B, C, D and E. The values you are seeing here, do you know that upper triangle, lower triangle concept? Don't know? No wonder. That is. That A is there here, B is there here, C is there, and A is there here, B is there here, C is there here. A to A, what will happen? Variance or covariance? Variance. A to B, what will happen? Covariance. And A to C, what happen? On this, fill the table now. Covariance, variance, covariance. And here, covariance, covariance, variance. Now these values both are same. Agree with me? And this is called upper triangle. This is called what? Upper triangle. And this is called the lower triangle. When you do this kind of analysis, upper triangle values, lower triangle values, both are same. Both are same. Now you see here again. What you are seeing, this is called upper triangle. V. Always what will come answer? 1 will come, 1 will come, 1 will come. That you already know that is. And this values A to B and same as what happened? B to A. So this value same. And this value will same. Similarly, this value will be same. B to C and C to B. And that is the concept of upper triangle and lower triangle. Understood now? Now similarly, if you see the values here also, 2794, this value is upper triangle, lower triangle look like. See that? Because A to A, there is no distance. Distance is what happened? 0. That's why his hyphen is there. That's why what is there? Hyphen is there. Note down these values. Shall tell me the values now. A to A, nothing. A to B, 2, 7, 9, 4. Next, 2, dash, 9, 11, 14. Next, 7, 9, dash, 4 and 8. Next, 9, 11, 4, dash, 2. Now see here, A to E means A to E is 4. You can fill directly at 4 here. E to B, that means B to E, that means 14. And this E to C nothing but 8. And this finally 2. That's why these values, what you are seeing is called nothing but upper triangle. What you are seeing is called, and this is what you are seeing is called a lower triangle. If you find something is enough, and then you can fill the matrix very, very easily. That is. Now, what you are seeing this table is nothing but the table is step 1. You can say that step 1 table. Step 1. Step 1 table. That is nothing but a similarity table. What the name is called? Similarity table. Similarity. That means similarity equal to similarity. Yes, similarity equal to similarity equal to 1 by distance. 1 by distance. That means before to form this table, there is a one more thing what happened, distance calculations will happen. That I am avoiding because yesterday we have solved that as many as can, right? The distance between the two observations. So think like that. You already calculated the distance between observations. You already calculated distance between observations, and you form this below table, and we form the below table, So what you are seeing table is called not distance table. It is the table is what? Similarity table. What is the similarity formula? 1 by distance. So you already calculated the distance between the each observations, and you form that a table. That is clear. Now, step 2. Step 2. Now tell me in the above table, which observations having highest similarity? Having highest similarity. Having highest similarity. highest similarity. Now tell me which pair is having highest similarity? E and B. 14, huh? 14 is the highest similarity. 14 is the highest similarity. So out of these observations, 5 observations, when you calculated the distances, who has the highest similarity now? No, this table is nothing but a similarity table. The table itself, which table? Similarity table. Table name is called similarity table. What you are seeing is called similarities, not the distances. The table name, I am writing here, right? What is the table name? Similarity table. Similarity is equal to 1 by distances. Assume that you already calculated the distance between the observations and you form the below table. So by using it is the similarities. So in the above table, which observation having highest similarity? E and B. So E and B highest similarity, that is called how much? 14. Paka, correct? Not understood? What is there not understood? And out of this, what is the biggest value? That's why biggest value attached between whom and whom? No. Highest similarity. Again, your people are confusing. This table is not distance table. Okay. What is the table name? Similarity table. What is the table name? Similarity, not distance table. Similarity means both are highest similarity are close or lowest similarity are close. Both are similar means highest value or lowest value? Highest value, right? That's why 14 is the highest similarity means both are close each other, not close each other. Huh? Simple question. Why are making it much complicated? Simple question. Two persons are having highest similarities. Means these are very close each other or can be clustered together or not can be clustered together. You are buying a laptop, I am buying a laptop. You are buying a bike, I am buying a bike. Next you are buying a pen drive. What I will buy? Then you are clubbing together, no? That means what happened? Highest similarity. Samjha now? Yeah. So EB is nothing but 14. Now here your diagram will be like this now. The diagram will be like this. Same, this is y-axis and this is x-axis. In this you have A will be there here. A will be there. And here what will be there? B. And here C. And here D. And here E. So which are become cluster now? Which are become cluster? E and B. And this is the height mean distance. Okay, this is a distance at 1 by 14. Now generally forget about this, that not a distance, it is a 0, take here 0 and this is the some value. Where should be 14 will be existed? Where is the 14 will be existed? Somewhere here generally 14 will be existed. But it is a, suppose it is a distance, y-axis could be distance. Now distance equal to what happen now? 1 by 14. Distance equal to what happen? 1 by 14, then similarity equal to how much? 14. Similarity equal to highest similarity, then distance is equal to what happen? Less distance. What your y-axis you need to fix it. What your y-axis here? Your y-axis is you want to make as a distance or you want to make similarity? Tell me what you want to make. Your y-axis is nothing but height. Height is nothing but a distance. What is that? Distance. So now these two are cluster here 1 by 14. Can I write like here 1 by 14 now? Can I write 1 by 14? Understood this concept? Simple concept. There are two lines are there. There are two lines are there. This is distance line. This is which line? Similarity line. You already know similarity is equal to what happen? 1 by distance. And distance equal to what? 1 by similarity. Correct? Now you said similarity is equal to 14. Similarity is equal to what happen? 14. Then what is the distance now? 1 by 14 should be here or here? 1 by 14 is here. Understood now? Understood now? This is 14 means this is a 1 by 14 because 0.000 something, right? 1 by 14 means. So this is a 1 by 14. At point of 1 by 14, 2 are become cluster B and E. This is the step 1. This is the step 1. Understood? Confirm everyone? Can you please confirm the chat? Now second, this is very, very important. Now A and B are completed together. Now the new clusters are A, C, D and EB. What are the new clusters now? New clusters. New clusters are what? A separately, C separately, D separately, and you combine what? E and B. Before how many clusters are there? 5. Now how many clusters are there? 4. That you are able to see in the diagram itself. 1, 2, 3 and these 2 are together. Now make the table like that. Now make the table. Which same value, Asma? Similarity same, you can pick any one. Understood. Same, you can pick any one. After you rearrange, right? Automatically it will come to that position only. E and B, you can pick any one. That is the next question will come. Okay, now you'll understand. That is, you'll understand now. A, your question is valid questions. Now you'll understand that. C and D and EB. Now, A to A again, 0. And this also 0. This also 0. This also 0. Correct? Now, fill this A to C. What is the A to C value? 7. Huh? What is A to D? 9. Forget about EB as of now. Now, this what will happen? 7. This what will happen? 9. D to C? 4. Huh? Just fill the table. What is this answer? Okay, that's it. Have you understand this? From the above table, A to C equal to 7, A to D equal to 9, and C to A is equal to 7 will come, and D to A is equal to 9 will come, D to C is equal to 4, that means C to D equal to 4. Is that clear now? Step 2. Now the question is, now A is there. Now what are the values between the, A and B? That is the question now. Correct? Why it is coming like this? Now the question is, A to EB, what could be the values? What could be the value? A to EB is what could be the value? Because you already know A to E. What is the value of A to E? 4. And what is the value of A to B? 2. Now you get a confusion. Which value you want to consider? 2 or 4 or average of 2 or 4? That is the question. Okay. which value you will consider? You want to calculate A to EB, but A to EB directly not will be available. What is available? A to E available and A to B available. A to E is how much? 4. A to B is how much? 2. Now there are, you want to take 2 or you want to take 4 or you want to take 2 and 4 of average. Now the 3 options are there in front of you. There are 3 options. So which one you want to take? That is the question. Is that understood, everyone? Question, can you please confirm the chat? Is that clear? Remaining values you are filling very easily, but A to EB is now little tricky because A to B directly not available. What are available now? A to E is 4 is there, A to B is 2 is there. Now which one you want to take? Either you want to take 2 or you want to take 4 or you want to take average. So the 3 options are there. There are 3 options are there. So we have 3 methods are there. And these methods are named called linkage methods. Linkage methods. 3 methods are there and that is called linkage methods. Linkage methods. One is called simple linkage. One is called simple linkage. And another one is called complete linkage. And another one is called word method. That is nothing but a average linkage. Average linkage. Simple ma? A to EB is directly value not available. So A to E available or A to B available. So A to EB is nothing but 2. A to E nothing but 4. Either you want to take consider 2 or you want to consider 4. No sir, I want to include both. Then what is that option? Average. So the 3 options are there. That method is called what? 3 methods. That method name is called what? Linkage method. One method is what? Simple linkage. One method is complete linkage. Another method is called word method. So these are important in the hierarchical clustering. Okay. Linkage functions are the very, very important. Now that if you see here, this is A to E4 is there, A to B now. 2 are there. So you want to take single linkage, you want to take complete linkage, or you want to take group linkage, nothing but a what method. Single linkage means what is that taking? Maximum value. Complete linkage means what you want to take? Minimum value. Group method, what is that? Average value. That also you note down here. Single linkage means take the maximum value. Take the maximum value. Complete linkage. Take the minimum value. And word method or group method, take the average value. You can take anything, ma, you can take anything. Simple linkage, complete linkage, word method. So generally, listen very carefully. Generally, there are 2 types of approaches are there. Approaches are there. 2 types of approaches are there. One is suppose person A and person B, same like this. Buying patterns. Buying. Person A is buying laptop and person B is buying also laptop. And similarly, person A is buying a TV and person B is buying a TV. And person A is buying nothing but a car and person B is buying a car. Now both are similar each other. Both are similar each other. You can assume that both A and B are clustered together. That's your assumption, correct? A and B are clustered together. This is the buying patterns. This is the buying patterns. Now observe that another scenario. Observe the another scenario. A is buying a laptop with 2 lakhs laptop and B is buying a laptop of with 20,000 laptop. Okay. Now he is buying a TV of 5 lakhs TV. He is buying a TV of 5,000 TV. 5,000 TV. He is buying a car of 20 crores. He is buying a car of 2 lakhs. Now can you combine both? A is a rich customer, B is a poor customer. You can't combine the both. You can't combine the both. Now A and B are together, not two together, are different clusters or different cluster. Like that you need to see, whenever you do any analysis, like that you need to see. Now what is your use case? You want buying pattern is your use case, or rich customers or poor customers your use case? Yeah, different problems have different use cases. That's why these methods are coming now. That's why these methods are coming. Now simple linkage is taking the maximum value. You might be asked why I am not taking the complete linkage. Again, complete linkage will go into the different groups. Simple linkage is going to the different group. Because these are the two perfect examples. Pakka they will ask you interview question. Simple linkage and complete linkage. Why to use, how to use. And you need to explain these two answers. Buying patterns and rich customer, poor customer. You can say that if you take the simple linkage, highest similarity, you can take this. Lowest similarity is nothing but automatically these two are similar, but they are in different group because that another feature is adding, that is a rate feature is adding. So this is very, very important understanding of this. These two cases understood or not? This will go with similarity and that will go to the general distance. So that's why if you take simple linkage, you will get different groups. If you take complete linkage, you will get different groups. So what is your use case? Based on that only, you need to take simple linkage or complete linkage. It is completely different on use case. Sir, I don't want simple, I don't want complete, I don't want confused, I will take average. Okay, le lo average link. Take the average. Most of the people prefer only average only because they want to go with other group of simple and complete, they will take the average. Because average is always the best solution, no? Whenever two values are there, simply take the average. Okay, some people will do simple linkage, some people will do complete linkage, some people will do average linkage. Okay, whichever you want to do, you do that. Okay, now offline girls will do simple linkage. Offline boys will do complete linkage. Online people will do average linkage. Done? Understood now? Offline girls will do simple linkage because we want to see the clusters now. Offline boys will do the complete linkage. Online people will do the average method. Now I divide in 3 groups now. This will do by online people now. And this will do by complete. This is by offline boys. And this is done by offline girls. Okay. I will do that simple linkage only, but don't copy me, okay? Chalo, start the work now. Now, this analysis. Now A to E. Now A to E. So I'm following the simple linkage. I'm following the simple linkage. So what is the simple linkage now? Maximum of 2, 4. That is called, what is the answer? 4. What is the answer? 4. Now A to B done. Now what is another thing? C to EB. C to EB. A to E done. A to EB is equal to, now tell me, C to EB. Tell me what is C to EB values? C to E how much? You do second method, no? Saurav. C to B. That is the 9. What is the maximum value? 8 comma 9. That is the 9 is the answer. I will do for you also, don't worry. Next, what is another thing? D to EB. D to EB. So D to E, how much? 2. D to B, how much? 11. Then maximum 2 comma 11. 2 comma 11, how much? 11. This is for simple linkage. This is for simple linkage. Suppose complete linkage, what do you take? Minimum of 2 comma 4, that is equal to 2. And the minimum of 8 comma 9. And complete the table. Complete the table ma. 8 comma 9. And minimum of 2 comma 11. And that is equal to how much? 2. Now I want to take average. Average of 2 comma 4. That is equal to how much? 3. And simply how much? 8 comma 9. That is equal to 8.5. And simply here also 2 comma 11, that is equal to 6.5. Fill the table now. Fill the table. Now I'm taking the table here. So we are following the simple linkage. Following the simple linkage. Now E to B, simple linkage is the 4. Okay. And C to EB, that is equal to 9. And this is equal to 11. So 4, 9, 11. This is the simple linkage. But we are following simple linkage, table ban gaya. Simple linkage. Similarly, you can do that complete linkage. Similarly, you can do that word method. Simple linkage is done. Second step is done. Tell me, Deepak, what happened? Good? Not good? Why? See. Huh? Come here. Very simple. First step. What is the highest pair? Similarity. Highest pair. Who is highest pair? EB. Before that, how many clusters are there? 5. Now, how many clusters are there? Now, बन गया table. Now, how many? 4 into 4 table आता? 4 into 4 table आया? Now, A to A. Again 0. A to C. 7. Because previous table is there. What is the problem here? A to EB. Correct? So, A to EB ko, you don't have a direct value. So what are the values are available? A to E available. A to B available. So, question is for you, which value you will take? Whether you want to take 2, or you want to take 4, or you want to take average. So, how many options are there in front of you? So, that's why how many methods are there? So, what is the first method? So, what is that? Complete linkage. What is that? Word method. What is that? Now, suppose you are doing that simple linkage method. Then, Barga table. What is the simple linkage method? A to EB is equal. What is the value? 4. Because you already know that 2 comma 4 say maximum value utana. That is 4, no? That's why A to B is how much? 4. That only, na? That only you need to explain these two. Problem. Generally, people will take average method. That is called hyperparameter, na? That is the next question. What are the hyperparameters in this? Choose by method is called hyper. Low entropy hai, G nahi hai. The same way, what is the method? You can choose that. That is the hyperparameter. Is that clear? How can I form the second table? Can you please confirm the chat? Now next question. Which is highest pair now? I am doing simple only. I will not do all. Which is highest pair now? The highest pair equal to 9, C and C to 11. Okay, D and EB. At which point? At which point that is equal to 11. That means distance is equal to how much? 1 by 11. Now here, come here. Now either 1 by 11. What will be either? 1 by. At this point, who are become cluster now? This one is coming and this guy also is coming and they are forming the clusters here. Understood now? Because B and E, no, you told. E and B. D, D. Okay. That means EB is coming like this. And next who will coming? D will come. These both are cluster at which point now? 1 by 11. Now again. Now what are the new clusters now? Step 3. Now new clusters are A is 1, C is 1 and B, E, D is another one. Now create table now again. If you are doing average method, it will be different. If you do simple method, different. It is do complete method, it is different. Okay. Create table now. Three into 3, 9. Now 3 into 3, 9. So either A आता, C, and here B, E, D. Here A, here C, here B, E, D. So A to A 0, you already know. A to C kitna? 7. Now here A to C 7 and here 0, here 0. Now the problem is A to B, E, D. A to B, E, D. So in that again, you already, what do you know that? A to D you know and A to B, E you know, right? What is A to D value from above table? A to D value from above table 9. A to B, E value from above table 4. From above table, from above table. If you wanted to practice, do simple linkage only with me and later at home you can do other things, okay? Now simple linkage, what I'm taking? Simple linkage. If you start with simple linkage, continue with simple linkage only. Don't misuse that. One table is simple, one table is average. Don't do that. Simple means simple only. Maximum of maximum of 4 comma 9. So what is the answer now? 9. And next guy is, what is the next guy? C to B, yeah. No, you already know C to D. You already know C to B, 4 comma 9. Huh? Then this is also 9. Oh. Then come here. Update the table. Here 9 will come. Here 9 will come. Here 9 will come. Here 9 will come. Now which have in the highest similarity now? Highest similarity. 9 is the highest similarity. All A, B, C, D are combined together now. All A, B, C, D together combined. Because what happened? What are now? A to B, E, D is there. And C to B, E, D is there. C to B, E, D is there. Both are combined, no? So all are combined. So A, B, C, E, D is the combined now. If you want to do extra one more thing, okay, then A, B, E, D is one thing, C, B, E, D is one thing. Extra. One more table will come. Again, that is the one answer will come. No, last. Anyhow, you know that only 2 are remaining. Now see here now. A to B, E, D. Who is B, E, D? This guy. This guy is, these both are matching at which position? 1/9 position. And C, this guy also will come. And C also will come. C also is coming. This also matching at what? That means automatically A is coming and C is coming. And this is what happened? B, D, E. This is nothing but B, D, E combined together. Here, who are combining here? Here at this position. Who are combining at this position? Tell me. This is coming. This is coming from where it is coming? B, E. This is coming from D. That's why it is become what? B, E, D. That's why it is coming as a B, E, D. Understood now? The graph? Again, I will repeat, ma. Don't worry. That is. Don't worry now. Understood now? Graph. It is time to understand the graph now. Now, first time everyone is the different observations. Everyone is a one cluster. That is the A is one cluster. And B is a one cluster. And C is another cluster. Similarly, D and E is a one cluster. And these are the observations. These are generally what happen of the points, observation of points. And here what is there? Distance. At 1/14, at 1/14, at 1/14, we have a one cluster is there. What are that one cluster? B and, so B is coming like this and E is coming like this, and both are 1/14 one cluster forming. Okay, both are one cluster. Next cluster you are forming with, see, next cluster you are forming with D to EB. D to EB. So now D is coming like this, and this both is coming like this, and this is 1/11. At 1/11 position, at 1/11 position, they both are combined together. This line, whatever you are seeing, this line is nothing but a D. This line is nothing but a BE. And this above is nothing but a BED. BED. Next, you are taking that. Now BED is coming and A is coming. They both are combined together at 1/9. And you already know that C also coming. C also coming to join this position. So this guy is nothing A, and this guy is nothing but BED, and this person is nothing but a C. And finally, all are meeting at one position. That is nothing but a B, C, T. All are one observations. You are starting with individual. At 1/9 position, you are combining everything. Now, how many clusters you want to take? That again depends on problem. You are drawing a line like this. You are drawing a line like this. Now tell me how many clusters are there here. This is one cluster. A is one cluster. And this C is one cluster. And B is another cluster, BE. And D is the another cluster. So how many clusters are coming? 4 coming. Okay. Now cut by using line. Now cut with a line ma. Like this, you cut the line now. Now you can do cut anywhere. Cut like this. At this position, how many clusters are forming? How many clusters are forming? What is the, this is one cluster? Confirm with me. Understood? What is another cluster? See, this is the second one. What is another? This is the joint point. This is the third one. And this is the joint point. That is the fourth point. At this line, how many clusters are there? 4. Suppose you are cutting like this. You are cutting like this. Cutting like this. Now, how many are formed now? This is 1. This guy is 2. This guy is 3. How many will form? 3. Now, how many parts you want to divide into groups as a people? Suppose you are a telecom customer. All the subscribers are same for you, know, from small to big. In that again, you want to divide into groups like old people, like ISD call people, data people, normal call people. Like that separately you want to divide. Then this is the way you can divide as many as you can. That is. So this is called dendrogram. What is called? Is called dendrogram. The name is called. Now you see here. It is a dendrogram. Are you seeing like this? Now every observation is the different observations. And finally at position of 14, we are getting what? All observations are equal one cluster and you can cut everywhere wherever you want. That's the distance. At which point of distance you want to choose how many clusters? Simple. There's a flexibility is there. You can number of clusters you can easily choose in this algorithm. That flexibility is there. You can choose 20, you can choose 200. How many you are choosing, that is again depends on the problem statement only. You can't choose very low, you can't choose very high. That is, this is called dendrogram. Understood the dendrogram concept? The beauty of Navi Bayes and decision tree and KNN and K-means hierarchical clustering, everything you are solving manually. Remember that. We are solving the data with manually. While you are doing solving, you will think about that, how it is working, right? And that after going to home, note down the points. Again, do that. Take a pen and book, again, do that. And if you have any problems are there, talk to me. But K-means and hierarchical clustering are there. K-means complete a distancing. Hierarchical is complete a method of linkage functions. These methods are important. Linkage functions. Simple linkage, complete linkage, what method? So these are the linkage functions. Now you are slowly understanding the difference between each algorithm, right? So every algorithm is uniqueness is there. Every algorithm the uniqueness is there because we have so much mathematics is there in our life, right? So every mathematics producing one algorithm. But these are the important. What we learned till now is that is enough, and SVM bagging recommendation engine is the little tricky algorithms, and that you need to concentrate more in the class. So whenever I'm teaching SVM tomorrow means and sleep by 10 o'clock only night. Okay. Otherwise you'll not understand that class. Sleep by 10 o'clock only. Simple. You got AD and CBE group, very good. But you understand the story, right? Overall story. Can you repeat now once again? What happened in hierarchical clustering? First of all the observations are individual clusters. Then what you are making? A symmetry table. And what you are taking from the table? Highest similarity. So what is the highest similarity is coming? EB. EB is equal to how much now? 14. So what are the new clusters? A, C, D and B and E. Now again form the table. 4 observations are there. How many rows will come? Columns and 16. And what is the problem here? A to EB is the problem. You don't know A to EB, but what do you know? A to E you know and A to B no. So how many options are there in front of you? 3 options. Either take 2 or 4 or average of 2 comma 4. So 3 options are there. Simple. How many methods are there? No need to by heart. It's a very, very simple common sense. If somebody asks to choose 2, 4 or average of 2 comma 4, no? The simple common sense. So for that maximum nothing but simple linkage, minimum nothing but complete linkage, and you will confuse in interview which one is maximum, which one is minimum. You know the names, but interview you will confuse which one is maximum, which one is minimum. Pakka. This is a confusion, one confusion question. Simple linkage I know, complete linkage I know, but interviewer will confuse you which is the maximum. Okay, this kind of games you should be perfect. And then maximum value, that is simple linkage we are taking. We are constructing a table. Again, we are considering that same story. What is the highest pair? 11 is the highest pair. Then new clusters are AC and BED. Again, same story. Understood? Now tell me which algorithm is easy out of this? Don't say KNN. If you are saying KNN means you are a lazy guy. The algorithm itself name is called what? Lazy algorithm. Okay. See, concentrate on this. These two. Concentrate on this one. Concentrate on these 3. Linear regression. If you learn linear regression, which is easy? Logistic easy. When you learn decision tree, this will be easy. Bang boosting easy. That only bang boosting. Without teaching random forest only, I will close the batch. Do you think that? Chalo. Thank you so much. See you tomorrow. Yeah, it is easy, na Nikita?
3 या 4 वैल्यू आ रहा है
हाँ.
तो लोग
It is same. Think like it is same. That is the question. 7.
there are 3 values
हाँ.
तो कोई सा भी ले सकते हैं लोवेस्ट वाला ही लेंगे
Lowest one. That is only we are using simple linkage, complete linkage, no?
कंप्लीट से किया तो लोवेस्ट लेंगे हम लोग हम तीनों
हाँ. और तीनों का लोएस्ट कितना? A to DB. So पहले A to DB आता. कंप्लीट लिंकेज इज मिनिमम दिखता है, मैक्सिमम दिखता है. अपोजिट. अच्छा. आई डोंट थिंक सो अपोजिट. अच्छा. Let me confirm that again once. But concept is same, no? Don't worry about that. Got the idea now? Practice చేస్తున్నావా లేదా? Hmm.
కన్ఫ్యూజన్ మ్యాట్రిక్స్ ఉన్న దానిలో ఎందుకు వాడతారు?
దేంట్లో తీసుకున్నావు?
పీపీటీలో లాస్ట్ కి టూ నెగటివ్ టూ పాజిటివ్ వాల్యూస్
అది మెట్రిక్స్ కదా.